Righty. And let's come back over here. And got some notes for you right there, sir. Good, 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 good. So again, y'all, glad to have you guys back. I hope you had a nice break. Um, so y'all, what we're gonna do today, hello, hello. I got some notes for you right there. We're gonna talk about confidence intervals for the mean. And so the first thing we're gonna do here, y'all, talks about estimating population parameters. So in this section, we're going to talk about how to use sample statistics to estimate the value of a population parameter. In this particular case, the population mean mu. Okay. So y'all, it says a point estimate is a single value estimate for a population parameter. The most unbiased point estimate for the population mu is going to be the sample mean mu, or sample mean x bar, I'm sorry. And so what we're going to do here, y'all, we're going to kind of figure out how to go through this stuff. So let's take a look at the first problem. So the first problem here, y'all, says the data below represents a random sample of the number of hours worked by 30 employees from several grocery stores in a county. So y'all, I'm going to stop right there. Let's think about Hidalgo County. Hidalgo County, y'all, is actually pretty big, right? I mean, I know most of us probably live in Hidalgo County. Some people might live in Cameron. But I mean, it's a pretty big county, because if you think about it, if you go to the west, y'all ever heard of La Jolla, right? Okay, so you still got to go past La Jolla. When you get to Sullivan City, which is probably about another 5-10 miles, that's where Hidalgo County ends in the west. If you go all the way to the east, it goes all the way to Mercedes, right? Because once you cross into La Feria, that's Cameron. As far north, guys, I mean, we're already, I'm trying to think. It's before you hit like San Perlita, because that's already Cameron County as well. But I mean, it's a pretty big county, right? So look, we're talking about 30 people that we picked that happen to work in grocery stores. So the biggest grocery store, obviously HEB, right? But again, Walmart, M. Rivas, you know what I mean? There's a ton of grocery stores, right? So what we want to do is we want to find a point estimate of the population mu. So these are the number of hours worked by 30 employees. So remember, y'all, if we wanted to find the average, and y'all, what I'm going to do here, I'm going to use my calculator to do this, and I'm going to do this like what we've been doing before. So again, y'all, just as a reminder, I'm going to go to stat, and I'm going to go to edit, right? And y'all, if there's stuff in your list here, you can always just go up to the top where it says L1 and hit clear, and then hit enter, and it should clear everything out. Okay. Now, y'all, I'm going to try to be real careless here, because a small mistake is going to throw the whole thing off, right? So look, I'm just going down, y'all. 26, 28, 32, 46. And I did this earlier today, y'all, so I know what the answer is. So I'm hoping that I get the same answer, or maybe I made a mistake earlier, but I hope I didn't. Okay. And again, y'all, I think this part right here, it's not difficult. It's just tedious, right? I got to enter all these numbers in, but not too hard to do.
How'd you get to the L
So stat, and then edit,
Okay.
and then go to list one. And if there's stuff in your list one, go to the top and hit clear, and then you should be good. Let's see, 36. Okay, the next one, 32. Okay, 28, 25. 35, 38, and then 31, and 25, and 22, and 22 again, and 32, and 28, and 21, and 26, and 32, and 22, almost, y'all, 28, and we got somebody working 40 hours, and 24. Oh, somebody's putting in some serious time at 48, and then finally, y'all, 19. Okay, and now, y'all, what I'm going to do from here, once I've entered in all my numbers, I can quit this thing. So the way I quit it, y'all, I'm going to go second and then mode. That's going to quit. I'm going to come back to stat, and we're going to go to calculate, y'all. So I'm going to calculate right here my one variable stats. And y'all, if you need to, you want to enter in list one. Usually it says like list and then frequency or something like that. On frequency, you don't necessarily have to put anything, but on the list, we definitely want to make sure that we got L1 there, right? Okay, so if we did this right, y'all, what I'm coming up with, my average here would be 28.9, right? That's my average. That's my sample mean, right? Out of these 30 people, the average number of hours worked was 28.9. Okay. Oops, sorry, guys. Yes, ma'am.
Mine it says like list, frequency list, but it's like not showing me.
Let's take
Like it says list three times, but on the second one it's just like that.
Yeah, you don't have to worry about it. And then just go ahead and go to calculate. There you go.
Oh,
28.9. You're welcome. You're welcome. Okay, so look, y'all, we found our sample average, right? Our sample mean. Now, look what it says now. It says, in this example, the probability that the population mean is exactly what we got, 28.9. It's virtually zero, right? So think about it this way. What do we mean by the population mean? By the population mean, we're talking about, we're going to take every single employee of every single grocery store in all of Hidalgo County. That's a lot of people, right? That's a lot of people. So what's the probability that if we took every single employee in the entire county that works at a grocery store, that the population average is 28.9? Probably not very good at all, right? But we can say with a certain level of confidence that the population mean is going to be in an interval close to 28.9 plus or minus something, okay? And that's what we're going to talk about, y'all, in chapter 6. So it says that the level of confidence C is a probability that the interval estimate contains a population parameter, assuming that the estimation process is repeated a large number of times. Okay, so y'all, I'm going to explain what this part right here means by looking at actually the first example. So if I scroll down just a little bit, y'all, and it's probably on the next page of your notes, but what we're going to do is we're going to find the critical value necessary to form a confidence interval at the confidence shown below. Okay, so y'all, what they're telling me here is, can we find a confidence interval when the confidence level is going to be 92%? That 0.92, y'all, means 92%. Let me explain what that means, y'all. I know we just got back from spring break. I know we've had a week off, but we all just took test number 2, and we were talking about the normal curve. So, y'all, I'm going to draw my normal curve right here, okay? This 92%, what that means, y'all, is that the area between two values here is going to be 92%. Both those values right here, y'all, this one of them is a negative ZC and the other one's a positive ZC. They're going to be the same number, except the first one will be negative and the second one will be positive. Okay, so the 92% is talking about there's going to be this interval in the middle where the area in the middle is 92%. Okay, now remember, y'all, the area under the entire curve is 100% or 1. So if I wanted to figure out what would the area be in those pieces, we could say, let's take 1 minus 0.92. So look, y'all, if I take 1 minus 0.92, everybody agree 0.08?
Yes.
Okay. So that 0.08, y'all, that needs to be divided. Yes, for those two spots. So we divide it by 2. Does everybody agree that this area here would be 0.04? Now, if I want to find, say, these values, okay, if I want to find these values, y'all, the way we could do it is we could use our calculator and we could come back to the inverse norm of 0.04, okay? So look, y'all, I'm going to come back here to my calculator. I'm just going to clear everything on my screen. I'm going to go second and vars. I'm going to go on, at least on my calculator, y'all, it's the third one, inverse norm. And we said 0.04, okay? And 0.04, Negative 1.75.
Mhm.
Okay, so look, y'all, this number right here, negative 1.75. This one on this side, guys, is going to be positive 1.75. Okay, y'all, we're going to be looking for the positive one. Okay, there's a couple of ways we can go about doing it. I think the easiest way is let's do this one, and then once we know that one, we already know that the positive one will just be the positive of that value. Does that make sense?
Sir, the negative 1.75, is that the area?
The area is 0.04, right?
So that's
This
the
gives me the z-score that corresponds to that, right? Okay, so we're finding those critical values, y'all. We're going to talk about how we find those critical values. That's really how we do it. Okay, so y'all, what we're saying is we can find, again, not the exact population mean, but we can find an interval where we say it's going to be 92% within, there's a 92% chance it'll be between these two numbers, okay? So, y'all, it says since X bar varies from sample to sample, there is something called a sampling error, okay? And we're going to figure out how we find that sample error, okay? So it says, y'all, given the level of confidence C, the margin of error E, sometimes called the maximum error of estimate or error tolerance, is the greatest possible distance between the point estimate and the value of the parameter it's estimating. For a population mean mu, where sigma is known, the margin of error is given by, and we got a little formula here, y'all, okay? And I'm going to walk you through the process and how we're going to do this thing. So there is a formula, y'all. My formula is right here, okay? And they're telling me, let's go ahead and round to one decimal place. Y'all, when I was doing the homework, one thing I noticed about some of the homework is they were telling you to round to 2. So I'm actually going to round to 2 in most of these cases, okay? So let's take a look. It says, use the data from problem number 1 and a 95% confidence level to find the margin of error. Okay, so you look, y'all, the first thing I want to do, I want to think about what does it mean to have a 95% confidence interval? Y'all, I'm going to draw my normal curve, right? It looks something like this. I'm going to have two numbers here, y'all. And I know that the area inside this part here is 0.95, right? So y'all, I need to figure out what's going to be the area this way and what's going to be the area that way, right? So remember how we do this. We're going to go 1 minus 0.95. That should be 0.05. But that area, y'all, is going to be cut up amongst two pieces, right? The part on the left and the part on the right. So let's do this. Let's take 0.05 and let's divide that by 2. Excuse me, y'all, I'm coming up with 0.025, right? So this area here, y'all, is 0.025. Remember, we're going to have two values, y'all. One of them is going to be negative, one's going to be positive. I'm actually going to find the negative answer, and then we can easily find the positive one, right? So look, y'all, if we wanted to find the z-score that corresponds to an area of 0.025, we're going to go second bars. We're going to go to inverse norm. We're going to type in 0.025, okay? And y'all, the negative value, negative 1.96. Does that seem right to y'all? Okay, so negative 1.96, but y'all, we want always the positive one, okay? It's just easy for us to find the negative one first, okay? Now, let's see if we can find our error, okay? The formula for my error, y'all, says we're going to take that ZC value, we're going to multiply it by the standard deviation, and we're going to divide it by the square root of n, okay? So let's see if we can figure that out. Look, y'all, we just found our ZC value. We found that number to be 1.96, okay? Now, y'all, in part 2, they're telling me, look, my population standard deviation is 7.9. So we're going to go 7.9 divided by the square root of, in the first problem we did, do y'all remember how many employees we surveyed? It was 30, right? Right, very good. It was 30, right? Because if you look up here, guys, it says 30 employees, right? So we're going to divide it by the square root of 30. Now, this part, guys, it's just strict calculator work. So let me clear this out. 1.96, okay, times 7.9 divided by the square root of 30. Close my parenthesis. And so, yeah, guys, I'm going to go ahead and go to 2 decimal places. I know in the notes I said 1, but again, I noticed a lot of times in the homework, they didn't want me to go to 2. So 2.83? Okay. 2.83. Okay, so what does that mean, y'all? That means that when we found our average the first time, I think we got something like 28.9. Is that what we came up with earlier? Yeah, 28.9. What we could say is there's a 95% there's a 95% probability that the population average would be 28.9 plus or minus 2.83 hours. We could figure that out, right? And that's what it's telling us. Okay. Guys, I'm going to do the same thing with part 3. Okay. It says a survey of random sample of 1,000 smartphone owners found that the mean daily time spent communicating on a smartphone was 131.4. From previous studies, it is assumed that the population standard deviation is 21.2 for a 90% confidence interval. Okay, so look, y'all, first thing I'm going to do, I'm going to do that 90%. Okay. Remember, y'all, that's telling me that the area in the middle is 90%. We need to figure out what's the area on the left and the right. So we're going to go 1 minus 0.90, 0.10. We're going to divide that by 2. So wouldn't that area there be 0.05? And this one also 0.05? Okay. So remember, y'all, we're going to, yes, sir.
What is, sir, I was following the homework on the homework on it anyways. It was telling us to multiply by 0.5, like 1.5, and it gives us the same thing, no?
To do what again?
So if you go 1 minus 90, right, gives you 0.10, and then if you get 0.10, and you multiply, it gives you 0.1, and if you multiply it by 2, by 0.5.
Yeah, it's the same thing because multiplying by half is the same thing as dividing by 2, right? Yeah. So look, y'all, we want to find those 2 ZC values, right? Remember, this one here is going to be negative. This one here is going to be positive. Let's first find the negative, right? So look, y'all, I'm going to come back to my calculator. We're going to go second vars. We're going to go to inverse norm, typing in 0.05, right? And so I'm coming up with negative 1.64. Okay, so my positive one, y'all, positive 1.64, right? Again, y'all, we're trying to find the margin of error. We're trying to find our error here, okay? So, y'all, the formula for us finding the error is to take that Z value, multiply it by the standard deviation, and divide by the square root of the number of entries we had here. So, look, we're going to take 1.64 times, let's take a look. Do we know what our standard deviation is? 21.2. Very good. And we're going to divide this by the square root of how many? What was our sample size? 1,000. Very good, y'all. So look, y'all, we're going to come back this way. Let's take 1.64. Let's multiply it by 21.2. And then let's divide that by the square root of 1,000. And hit enter. And y'all, I'm coming up with what, 1.10? If I go to 2 decimal places, right? Should be 1.10, right? Because it's 1.099. And we found our error, right? Okay, so again, y'all, let me scroll down a little bit further. And let's take a look at the next couple of problems we got here on our list. Let's see if we can't figure this out. So, y'all, if we know our point estimate, which is the sample mean, and we do know what our population mean is, the easiest way to find our sample error, y'all, is just to use this formula right here. We're going to take x bar minus mu. So to find the error, y'all, we're going to go X bar minus mu. So in this case, y'all, my X bar is 3.8. Our population estimate or population mean is 4.19. And again, y'all, I'm just going to subtract 3.8 minus 4.19 and negative 0.39. There you go. Oh, come on down. Sorry, guys. Sometimes my pen freezes. Negative 0.39. Oops. Okay. Y'all, I'm going to do the same thing on the second one. Okay. X bar minus mu. 24.02. I'm sorry, you came up with 1.47?
Yes, sir.
There you go. And you got it. Take it away. Okay.
So that would be your answer, sir?
That's your answer. And that's just what the error happens to be, right? So we're a little bit above, right? My sample average is a little bit above the population one. That's why it was positive. Over here, our sample average was below the average. That's why it's what? Negative? There you go. Right.
Is the 1.47, is it positive or negative?
So this one here should be positive, right? Because it's always X. So the formula is always X bar minus mu. So my X bar here was 25.49, right? So my error can be negative, right? If my population, I'm sorry, if my sample mean is smaller than the population one, that means my error is negative, right? Because I was below. Yeah. So look, y'all, we're going to figure out now, how do we find, sorry, all my mouse is freezing up too. Oops. Okay, so now sorry guys. Now we're going to figure out, let me come back this way. How do we find, let's do it this way. Here we go. How do we find a confidence interval? Okay. So look, y'all, number 4 says, this is how we're going to find confidence intervals. Y'all, I got a little formula for us right here on how we find our confidence interval. Okay. It's going to be our sample mean minus the error and our sample mean plus the error. Okay. So, and we already know how to find the error. So look, y'all, number 4 says, can we construct a 95% confidence interval for the mean number of hours worked by the grocery store employees from problem 1? Let's do this first, y'all. In the first problem that we did today, after we did the average, does anybody remember what our average was for the very first problem we did this afternoon? That was the number of employees, but what was our average? 28.9, right? Okay, awesome. Now, y'all, we actually found the error for 95% confidence interval. I think if I come back over here, here we go. Look at problem 2. Didn't we find the error for a 95% confidence interval? And what number did we get? We came up with, what, 2.83? Okay, so look, y'all, that was my error. So I'm going to come back here, 2.83, okay? The way we're going to find our confidence interval now, y'all, we're going to take 28.9 minus 2.83 and 28.9 plus 2.83. And let's see if we can get what those numbers are going to be. It's giving us the left side and the right side. That's exactly what it's telling us. It's telling us what's the lower limit and what is the upper limit. Okay. 28.9 minus 2.83, 26.07. And then what about the other one, y'all? 31.73. There you go. So what we're saying, y'all, is that we are 95% confident, meaning there's a 95% probability that the population average is going to be between those two numbers. Okay, that's really what a confidence interval tells us. Okay. Now, let's take a look at number 5. Number 5 says, can we make a 95 or 90% confidence interval for the problem dealing with the telephone. So look, guys, I'm going to come back over here. I'm going to go back to my telephone. Couple of things I want to point out here, y'all. In the telephone problem, okay, look at what our mean was, 131.4, and we found our error to be 1.10, okay? So look, y'all, I'm going to write it right here, 131.4 with our error to be 1.10, okay? So we're going to do the same thing, y'all. 131.4, oops, minus 1.1, comma, 131.4 plus 1.1. So I want to say this is going to be 130.3, and this should be 132.5. Does that seem reasonable? There you go. And you got it.
Sir, but you said you got the 131.4
From the question itself, right?
Ah, okay.
If I scroll back up, tells me right here, here was my average, right? They already gave that to us.
Gotcha.
That make sense?
Yeah, and the 1.1 you got it.
When we did that problem, that's how we got our error to be 1.1, right? Now, y'all, there's a way we can do some of the stuff on our calculator without having to do so many calculations. So I'm going to show you that now, y'all. So let's take a look at the next problem here. It says the college admissions director wishes to estimate the mean average of all students currently enrolled. We got a sample of 20 students. The mean is 22.9. Population standard deviation is 1.5. We're going to do a 90% confidence interval. So look, y'all, first thing I'm going to do, I'm going to go to my calculator. Let me clear everything out here. Okay, my calculator, y'all, I'm going to hit the button that says stat. Over here where it says tests, I'm going to scroll down to tests. And I'm going to go down to where it says the Z interval, which is, at least on my calculator, y'all, it's number 7. Okay, I'm going to hit enter. Okay, and we're going to go, see, first thing it says data, and then it says stats. We're going to go to stats, okay? And then I'm going to come down here, and let's see. My standard deviation, what did we say our standard deviation was in this problem, y'all?
1.5.
Okay, yeah, but why is it not going? Sorry, guys. Stats, there we go. Hit enter, there we go. Okay, better, sorry. Okay, so 1.5, right? 1.5, boom, boom. Okay, what is our average here in this case? They told us the average, I'm probably covering it up. 22.9, right? So right here, guys, where my X bar is, I'm going to put 22.9. Okay. How many students did we sample here? 20. So on my thing here, guys, I'm going to change that to a 20. And we want to do this for what level of confidence? 90%. So guys, right here where it says 0.95, I'm going to hit 0.90. Okay. And then you can go down to where it says calculate and hit enter. And guys, it should give us our interval. Okay. So y'all, when you're doing this again, in my lab, y'all, they usually ask you to go to 2 decimal places. If it tells you to go to 1, go ahead and go to 1. But here's my interval, 22.35. And to what, 23.45? And there we go. What do you think? Working out okay?
That's super cool and fast.
Right? A lot easier than having to go through the whole process, right? Again, guys, we went through the whole process so we can get the picture of what's happening, right? But look, now we can use, that's the whole point of the technology. Guys, I want you to think about stats like 50 years ago. Man, it was a pain. You know what I mean? Because we didn't have all this kind of stuff, right? It was just much more complicated to do. Guys, I'm going to come back to this problem in a minute. Let's do the next couple of questions, okay? And actually, the next 2 I'm going to skip right now. I'll come back to them in a second, okay? But I want us to see if we can do these next couple of problems here, okay? So I'm going to the one where it says we're given a sample mean and the population standard deviation. We'll come back and do those other 2 problems in a minute, okay? Okay, so look, y'all, I'm reading through my question here, okay? Random sample, 55 home theater systems. Mean price is 117. Population standard deviation is $19.10. We want to find a 90% confidence interval, okay? So guys, I'm going to come back here. I'm going to clear everything. I'm going to come back to stats. I'm going to scroll down over to tests. And again, I'm going to come back to my Z interval, y'all. Okay, we're going to stick with stats here, okay? So look, our standard deviation is $19.10. Okay. Our average is 117. Okay. How many theaters did we look at? 55, right? Okay. And guys, we are doing 90%. So I'm going to leave that as 0.9. I'm going to go to calculate, and here we go. So y'all, remember, this is talking about money. So I want to definitely go with 2 decimal places here. So the first one, y'all, 112.76 to 121.24. Okay, there we go. That's the 95 or the 90% confidence interval. Okay. Now look, y'all, when we're going to do the next one, the 95%, guys, I'm going to come back, stat, tests, scroll down to Z interval. Oops, Z interval. Okay, everything is going to stay the same with the exception of this. My confidence level, if it's 95%, y'all, 0.95. Let's go to calculate. And now we got different numbers, right? So look, 111.95 to 122.05. Okay. Now, y'all, again, what we're talking about here is we're looking for the population average, okay? So number one, what I'm going to do is when I start to look at my choices A, B, and C, I want to make sure that I'm talking about population. So y'all, if I look at part C, I can see that part C says sample mean. I know it's not that one, okay? So it has to be either A or B, okay? Now, y'all, think about this in terms of money. We're saying that the average for a home stereo or home theater system should be between $112.76 to $121.24, or $111.95 to $122.05. Which one is wider? Which one covers more values? The 90 or the 95%? The 95% is wider, right? Because it covers more. So look, y'all, I'm going to choose A. Why? Because it says the 95% is wider than the 90. Does that make sense? Right? It covers more values. Right? Makes it super easy to do, doesn't it? Look, y'all, let's do the same thing for this next question. We're given a sample mean and sample our population standard deviation. Okay, what are we talking about here? We got 62 days, and we're talking about recording the high daily temperature in a particular city. Oh man, look at that city, 82 degrees. Y'all, I'd die for 82 degrees every day. That's the high. Okay, let's do the same thing, y'all. I'm gonna come back here, clear my screen. Let's go to stat, let's go to tests. Let's scroll down to Z interval. Oops, Z interval. Here we go. Okay, let's start changing some numbers. My standard deviation in this case, 13.91. Okay. All right. What is our average? 82.37. Okay. How many days did we look at? 62 days, right? Okay. Confidence level. The first time, y'all, 90%. So 0.90. Okay. So far, so good. We're going to go to calculate. We're going to hit enter. And again, y'all, I'm going to go ahead and go see, this is what I said. See what it says, round to 2 decimal places. That's why I was going with 2. So the first one says our temperature ranges should be between 79.46 to what, 85.28? Okay. All right. Second time, my friends, I'm going to come back. We're going to do this with a 95%. Everything is going to be the same. Stat, tests, Z interval, We're just going to make one small change right here, make that a 0.95, go to calculate, hit enter. Excuse me. Now, y'all, I'm looking at 78.91 to, what is it, 85.83?
Yes, sir.
Okay, which one is wider? Which one covers more temperatures? The second one, right? Guys, the higher percentage is always going to be the wider one. Okay, it's always going to be the wider one. What do y'all think? Confidence intervals, easy breezy cover girl? So far it is, right? Good. Guys, it stays this way. It doesn't get more difficult, okay? Okay, so now, guys, we'll come back and do those last two problems in a minute, okay? But here it says, as the level of confidence increases, the confidence interval widens. And as it widens, the precision of my estimate is going to get lower. So one way to improve the precision of an estimate without decreasing the level of confidence is to increase the sample size. So how do we find our sample size? Okay. So y'all, look, if we have a confidence level and we have a margin of error, we can find the minimum sample size by using this formula. Okay. So look, y'all, let's see if we can do this for our problem. First thing, y'all, look what the confidence level they're giving me, 98%. Okay, look, y'all, I'm going to draw my picture here. Okay. My pictures are not great, but they get the point across. That means that there's 98% area in the middle. So if we take 1 minus 0.98, everybody agree 0.02? But then what do we need to do with that 0.02? Divide it in half, right? So wouldn't this part over here, y'all, be 0.01? Okay. So let's see if we can find the negative one first, and then it's real easy to find the positive one. Okay. All right, let me clear this out. Remember, my friends, second vars. We're going to go to inverse norm. We're going to type in 0.01 and negative 2.33. So the positive one, y'all, 2.33, right? Okay, let's see if we can find our number size n, okay? Right here, guys, ZC, sigma divided by E all squared, okay? We just found our ZC to be 2.33, okay? Times my standard deviation, guys, is 5.6 divided by my error, which they're telling me is 1 in this case, and we're just going to square that. So y'all, I'm just going to use my calculator again. Let me clear this out. 2.33 times 5.6 is that, do we need to divide it by 1? What do you think? Is it going to change it?
No.
Nah, it's not going to change it, right? So I'm not going to worry about dividing. I mean, you can divide it by 1, but it's going to be the same thing. And then we need to square that, okay? Look, y'all, when I square it, this is the number that I'm coming up with. My friends, we are always going to round up. So even though I'm coming up with 170, when we round up, y'all, we're going to get 171. Everything is going to be rounded up, okay?
So what's the square?
Right here, right above the log button.
Yeah.
There you go. Should be the square button right there. There you go, and you got it. You're welcome. You're welcome. All right. Y'all, let's try another one. We'll do it real similar, okay? We're looking for minimum sample size required when we're going to be 90% confident. Okay, y'all, first thing I'm going to do, I'm going to draw my picture here. Okay, 0.90. So remember, y'all, if I want to find what the area is left, 1 minus 0.90 should be 0.10. Y'all agree that each of those sides would be 0.05? Okay. Oops, sorry. So look, y'all, we're going to go second vars, inverse norm, 0.05. Let's close that off. Y'all, I'm coming up with negative 1.64. So this one here, positive 1.64, right? Okay, y'all, I'm going to write down my formula again. ZC times sigma divided by E all squared. Okay. So let's start filling in the blanks here, y'all. 1.64. Look, they gave us a standard deviation, my friends, of 15.2. My error, let's see. Look, y'all, my error is going to be what number again? But my error, though, right here, y'all. 1, right? 1 unit away. Okay. So again, y'all, I'm just going to use my calculator right here, guys. Let's take a look-see. Let's go 1.64 times 15.2. Again, y'all, question, do we need to divide it by 1? Nah, right, because it's a 1. Guys, if it was 2 or 5 or whatever, we'd divide it, but we don't need to, okay? Let's square it. Y'all, remember, I'm going to round up. 621 or 622? 622. Okay. And that's how many sample size we would need in order to do all this stuff. Okay.
So even if it's like smaller, we always round up, right?
Always round up. Every single time. Always round up. All right. So y'all, there's 2 more problems that I skipped. So let's come back and let's take a look at these problems over here, y'all. These problems are actually easy breezy, cover girl. I just wanted to do those other ones because I felt like it was using that z-interval test and it was easy to find them. Y'all, what I want you to notice about these 2 questions, they're both the same type of problem, but what we want to do is we want to find the margin of error and our sample mean. Y'all, the way we're going to find our sample mean, X bar, is we're going to take the 2 values that we have at the ends, we're going to add them together, and we're going to divide by 2. Okay. So look, y'all, I'm just going to grab my calculator here. Let's move this over. Let me clear that out. 0.422 plus 0.580. And let's divide it by 2. 0.501. There is our sample mean. Okay. Now, the way we're going to find the error, y'all, a couple of ways you can do it. The easiest way, you're always going to take your upper value. The easiest way to do it, take the upper value, 0.580, minus what we just came up with for our sample mean. So 0.580 minus 0.501, and my error, y'all, should be 0.079. There you go. Oops. Sorry, y'all. There you go. 0.079, right? And there's my error. Okay. So look, y'all, let's try the next one. It's the same sort of setup. A biologist reports a confidence interval when estimating the mean height in centimeters. Okay, let's see if we can find our sample mean. So y'all, I'm going to take 3.9 plus 4.3, and we're going to divide them by 2. 3.9 plus 4.3. Let's divide it by 2. 4.1. Okay. Now my error, y'all, I'm going to take the bigger value, the upper value, minus my average, and you should be getting 0.2. And there's our error. Okay. Guys, you can also do the average minus the lower one. So if you took 4.1 minus 3.9, you'd still get 0.2. Okay. You're just finding the distance between the sample mean and either the upper limit or the lower limit. Okay.
Sir, and we only do this whenever we have the wording of like this.
When they actually give you the confidence interval, it's really easy to find the sample mean because you add them together and divide by 2. right?
I'm just looking for keywords to tell me, hey, use this formula.
Yeah. Yeah. Guys, that's 6-1. All right. Tomorrow, guys, when we come back to class, or I'm sorry, Thursday, we'll do 6-2. Y'all, just to give you a heads up, the only difference between 6-1 and 6-2 is that in 6-2, we will not know the population standard deviation. We'll know the sample standard deviation, but there's a process on how we can find that. Okay. And I'll show you how we're going to do all that stuff on Thursday. But everything else is going to be pretty much the same, guys. Okay. Anyway, that's 6-1, y'all. The homework for 6-1, let me stop recording. Stop it.